This designer handbag looks really smart. You can put your phone and your makeup in it and go out on the town, yet it costs like 10 times less than you'd expect for a designer product. It's a fake. And that's the sense in which a fake test double operates. It looks great. It even works. It's just not the real one. But it can be really useful for making your unit tests faster and more reliable. In this guided learning hour, we'll learn about fake test doubles. Hi, I'm Emily Bache, software developer and creator of Salmon Coaching. I would like to thank my sponsor, Tuple. They make a tool for remote ensemble and pair programming. A small, bootstrapped team of engineers who care deeply about software quality. I've tried Tuple, and it worked well. It was really smooth, especially to switch who is typing. It feels great to partner with like-minded people and have Tuple as our first sponsor. If you're looking for a tool to make pair and ensemble programming easier, more effective and fun, check out the link in the show notes. This is a guided learning hour. It's designed to be done together with your team. And if you haven't seen one of these before, I recommend you watch to the end because the last part is a session briefing where I explain the format. Let's go to the shared online activity board that I've prepared.
To begin with, I've got some code for you to review. This method converts to HTML, opens a file and gets all the text in it, converts it to HTML and returns it as a string. So it's needing to add some HTML tags and escape some special characters. The trouble is it's got some bugs in it, really obvious bugs that I've marked with comments in the code. So the first thing I want you to do is read this code and discuss how would you write a unit test or several unit tests for this code. What kind of design decisions are you going to be making in those tests? Of course, I don't know what you've been discussing and what design ideas you've had, but I'm expecting that somebody will have pointed out you're going to need to have some kind of file that the test uses to test this. A file with different contents to expose the bugs in this. Now that is probably fine and a good approach, but there are some people who would say that a unit test that needs an actual file is not really a unit test. And this comes from Michael Feathers. In his book, Working Effectively with Legacy Code, he says it's not a unit test if it talks to the database, or it communicates across a network, or it touches the file system, or if it needs some very specific environment that it runs in. And he says all these things because he wants your unit tests to be really fast and really reliable. And all of those things are going to make your tests slower and potentially depend on things in the environment that you don't really control. Now, looking at this list, the file system is actually the most benign thing. I mean, it's not all that slow and it's actually fairly reliable. But the techniques that we're going to discuss today will also work when you've got a database or communicating over a network, and those things are generally pretty slow and unreliable and we'd like to avoid them. So let's learn some techniques that we can use on a file system that also work in those other situations. What we need here is a test double, because the unit we want to test has got this awkward dependency, and instead of using the real file in the test, we want to replace it with an object that we control. So just to explain the name test double, it's an analogy with stunt double. Like when you're watching a film, if it's the actor's doing something dangerous, the person you're watching might not be the famous actor you've heard of, could be a stunt double, who looks and behaves like their counterpart. And so a test double is the same. The system under test doesn't realise that it's dealing with a different object. It looks and behaves like the real one, but the test can be in control of the behaviour of that object. So that's really useful. The first thing we need to do is work out which object it is we want to replace with the test double. And at first glance, it might look like the file name, since that's what we passed the method. But no, the file name is just being used to get the file, and that is the object that we want to replace. So the file name is being passed in and then used to get a file from this open method. And that makes it a little bit awkward to replace it with a test double because we need to somehow affect what open would return, and that's like a built-in function. So we're going to be a bit sneaky and do something slightly different. The part of the code that contains the bugs only uses the file, not the file name. So we could do a safe refactoring without tests that just would extract this piece of the code, and that part would then only depend on the file object, and that would be a parameter to the new function. And that would make it much easier to replace it with a test double, because the test could just pass in a different object with the same interface. So that's the theory. Let me show you that in practice.
In this demo, I'm going to show the HTML converter Kata. You may be using a different programming language from me, but the underlying design challenge is the same. So I want you to focus on the way I'm using a test double to get the code under test.
This is the code that we're working on today, the HTML converter. There's a little bit more code that I didn't show you before though. I've also included this main function, which you can use to run this code on the command line with an actual file. So let me just show you the test file that I've also included. It's just got some text in it with several lines and some of those characters that might need escaping. So when I run this, it works. It shows the text that it's produced. And as you can see, it's not valid HTML. We've got bugs here. So that's one of the bugs. That's another one of the bugs, not closing paragraphs properly. And then these special characters over here have also been converted. So you might want to work out if it's doing that correctly. Okay, so that is a manual test, but we actually want a proper unit test that will run independently of us needing to do anything and won't need an actual file. So I've done some preparation work here. I've got two empty test cases here with names that indicate which bug they're trying to check for. And I've also included a couple of test doubles. So I've got a stub empty file and a stub 2-line file that you might want to use in your tests. I've done this for your convenience. There are several different ways of doing this with test doubles, but to begin with, I want you to try and use these stub test doubles that I've provided. But before we can use these test doubles, we are going to need to extract a function that's actually testable, which allows us to inject these test doubles instead of using a real file. My first move actually is to rename this variable f. F is not a very good name for a variable. Text. This is the text that we want to convert. So now when I extract this function, it's got that as an argument, and I can call this function convert text to HTML. Okay, so that's hopefully a safe refactoring. I'm going to run my manual test again to check. Yeah, I'm still getting text, but it's still wrong. And now I can actually write a unit test for this function.
Are you enjoying the session so far? Please remember to like the video and subscribe to my channel. You can support me and get additional materials from Patreon too. I suggest you check that out.
So this is the unit test I want to write first. This is the check for the valid HTML tags. So I'm going to call my new function here, and I want to give this an empty file. The first bugs I can get with no text at all, actually. So I'm going to give it this empty file stub that just raises a stop iteration as soon as you try and ask it for any text. And the result that I'm expecting here then is that empty HTML file. So I can assert then that that result text will be just an opening HTML tag and a closing HTML tag that should be properly formatted. So when I run this, it fails, which means I have successfully exposed that first bug. You can see here in the test report that the actual HTML I'm getting is not HTML. So that's great. So that was what I was hoping to do with my first unit test. And now if I go and actually fix this bug and make that a good HTML tag, the test passes. So that's good. That was the first thing I wanted to check. But it's not the only bug that I've got here. The second bug, I actually need something that isn't empty, something with more than one line of text. So that's what I'm going to leave for you to do in a moment. And I've prepared for you a stub test double here with a function that will return 2 lines of text in the stub file. So I suggest you use that. These instructions on the activity board will help you to remember what you're supposed to be working on. So I hope you have fun with this exercise. In this first exercise, I got you to write tests for this code and replace the file with a stub test double. And now there are several kinds of test double, and this taxonomy or naming system is by Jared Masaras, and I have other videos explaining more about the other kinds. But just to summarise, stubs will only give specific responses. They shouldn't contain any logic or behaviour. Spies will record interactions with other objects that you're testing, so that you can check them afterwards. Mocks are similar, except they expect interactions up front and will complain directly if they don't get them. And dummies are just empty or null. Today I want to look more closely at fakes though, because fakes have an alternative implementation and they can be very useful when the thing you want to replace is something like a file or a database that has a very standard interface and many implementations. I've put the bug back in the code now because I want to show you a different way to write the test, this time with a fake. So I'm going to take this test I wrote before and just duplicate it. And I'm going to have to rename it, of course, so that I don't get two tests with the same name. And this one I'll just say it's the same test, I'm just doing it with a fake. So here, instead of this stub that I have hand-coded, my stub empty file, I'm going to replace this with a fake. And there happens to be a very appropriate fake implementation that I can use here, which is the string IO class from the IO module, which is part of the Python standard library. And the string IO class, it behaves exactly the same as a file, except there's no actual storage on disk. And you have to pass it the string that it should contain to the constructor like this. So I'm passing it an empty string. Now this is code that I didn't have to write. The IO module is in the standard library. And if you're using a different programming language, I'm sure you're going to find something in the standard library that does this. And it is actually very convenient to use in a test like this. So let me just show that this does do exactly the same as the other one. If I run all these tests now, I'm expecting these both to fail, with the same error message. Both of them are detecting that first bug with the HTML. This is the code for the stub that I got you to use at first. And as you can see, it's got no logic or complex implementation. The only thing it's keeping track of is how many times you've called it. And it's just going to return the answers that you prepared it with. But it's got the right interface. It behaves enough like a file that it works for the purposes of the test. But I did have to do some work to write this. And if I had to do any more, if I actually made this into a proper implementation, then it would be a fake. And I don't need to write my own fake because there is one. This is the test we wrote using the fake. And as you can see, it's assuming that there is already an implementation of the fake. It works for the purposes of the test. And it upholds most of the contract that a user would expect. But there is an aspect that it doesn't uphold. It doesn't have persistent storage between invocations of the program. But we don't need that in this test, so that's fine. I would characterize this as a fake, and I would like to compare it with a designer handbag that is suspiciously cheap. It works as a handbag. You can put your makeup and your phone in it and take it out on the town. But it's made of cheaper materials, and the designer was not the famous one that they're trying to imitate. So this string IO object that we've used in this test, it works like a cheap designer handbag works. It upholds most of your expectations, apart from, it's not quite durable enough to use for real. And for this fake, there was one in the standard library. But if it's not such a standard interface as a file or a database, you could write your own implementation of some thing that you're calling over the network, for example, that you need to have actual behavior, and it would be easier to do that than it would be to try and stub all of the calls. So this is always a decision you need to make. When you've got an awkward collaborator, what kind of test double am I going to replace it with? And the stub is very limited with only the specific responses that you set it up with, whereas the fake, you might be quite a lot of work, but you could write a proper implementation, but that might be flexible enough to use in a lot of different test cases. So that could overall be a better choice. Let's do a bit of more hands-on practice. I want you to go back to the code that you were just working on and copy the tests you have and rewrite them to, instead of using the stub, use a fake and use the built-in fake that your language has, that string.io in Python. There are for other languages. I'm sure you'll find one. And make sure that the test that you write will still fail because of the bug and still pass when you fix the bug, so you know they're testing the right thing. I hope you've had fun with this second part of the exercise too, and that you've learned something about stubs and fakes. So just now at the end of the session, it's your chance to write your future self a note, to remind yourself what it is you need to remember about the important differences between a stub and a fake, and perhaps some note about when you might choose to use each kind.
So when you're writing tests today and thinking about how to replace a slow or awkward collaborator for testing, think about whether you might be able to use a fake. Happy coding! This is the session briefing, intended for the developer who's going to host this guided learning hour. And if you haven't done one of these before, I've got another video, Guided Learning Hour How To, that has more information. You'll also need some supporting materials, code samples and an activity board. The code is on GitHub and you can get the board from Patreon. Of course, if you like this content, please subscribe to my channel and like the video. In this particular guided learning hour, there are several points where I ask you to pause the video and lead activities with your team. It shows here on the screen roughly how long each activity should take, so that you can keep track during the session. It really helps if you can get the exercise set up beforehand, so you don't waste time on that in the session.
In this guided learning hour, there are 4 points where I ask you to pause the video and lead an activity with your team. We've got a connect and then an exercise in 2 parts, and then a conclusions. Let's go through them. In the connect, the main point is for people to read the code and do that at their own pace. So put them in breakout rooms, give them a time limit, and give them time to just read the code. You're not really expecting them to write notes on the board, although they might do, and they might start thinking about different texts that they'd like to use in their tests. And that's a good sign. It could be useful for the next part, but don't worry if people are just spending that time reading the code. As ever with a coding exercise, it's really useful if you can get people to install all the refactoring tools and the testing tools that they need before they start, so that they're ready in the session to get going with the actual exercise. I do suggest you work in pairs, because I've given quite a lot more code to start off with than they actually got to read before in the Connect, and some people will want to go through this carefully and see what the main method does and see what these stub file objects are doing, and that can take some time. It's easier to read code when you're in a smaller group, so I don't suggest you do this part altogether. But that will lead to people going at different speeds, and if people are particularly fast and they've written tests for the first 2 bugs that are marked in the code, they think they're done, well, they can add more tests for different texts with special characters and that kind of thing. There isn't a spec, so they can't really check whether they found any new bugs. But that's not really the point. I just want them to experience what it's like to write additional tests and additional stub file classes, and that actually you do need probably a different stub file for each test, or you end up implementing a fake, which is what hopefully they'll find out in the next part. Because the second part of this exercise, we're going to replace those stubs with an actual fake. And if you're not using Python, which I use in the demo, you could perhaps prepare in advance and check what does the standard library have that would be suitable for you to use as a fake file here. The other thing to do is to make sure people are actually retaining the previous tests, the ones with the stub, so that they can put them next to each other and get a side-by-side comparison of the same test with the stub and with a fake to help them to understand, well, what are the differences, what are the trade-offs here? Then in the conclusions, you want to have some quiet and everyone just to be able to think and reflect for themselves and work out, well, what did I take from this? What have I understood now? And put it in my own words, because your own words will be much easier for you to remember than anything I say or anyone else says. So your job as a facilitator is not so much to talk in this section, but to give people encouragement that they could write something, and that would be a useful thing for them to do.
I can assure you, this learning hour is more fun to do in a group than just watching this video. So if you do try it with your team, please let me know how it goes in a comment or on social media. Plus, you could join the Saman community of technical coaches. Do take a look at our website for events and training. Saman Coaching, growing excellence in coding, together.